all know that Coulomb's law states that if two charges Q1 and Q2 are separated by a distance r in air or in vacuum, then the force of attraction or repulsion is proportional to product of the charges and inversely proportional to the square of the separation between them. Now, in board exam, maybe in central board or in state board, it is asked several times that if the form of the Coulomb's law was in the form of 1 by r cube instead of 1 by r square, then what will happen to Gauss's law? Now Gauss's law states that total flux, that is closed surface integration 1 by E dot ds is equal to total charge over epsilon naught. Now, if the Coulomb law has the form of 1 by 4 pi epsilon naught q1 q2 by r cube, then this law is valid or not? This is the question. So first I want to explain you that why Gauss's law holds good. So think about that you have a charge here. Now Gauss's law states that you can take any surface here, here, or maybe much bigger. The flux through this all surface, this smaller surface or in this larger surface, the total flux will be same in the both cases. Why this is so? I explain it here that if this distance is r1, this is r2, then the electric field here, that is electric field on the circumference at any point, is given by E is equal to 1 by 4 pi epsilon naught q over r1 square, and electric field in this whole surface is given by E2 is equal to 1 by 4 pi epsilon naught q by r2 square. So electric field is larger here and electric field here is smaller. So we know that electric field decreases square in square form as you increase the distance. Now if I apply Gauss's law in these two surfaces, then what happens? First I apply Gauss's law in this surface, say this surface is S1. So Gauss's law in S1 is given that flux phi 1 is equal to E1 into 4 pi into ds1, that is E1 mean 1 by 4 pi epsilon naught q by r1 square in total surface area is 4 pi r1 square. So r1 cancel here, 4 pi cancel here, this gives q by epsilon naught. Now in case of surface 2, that is this surface S2, it still gives that phi 2 is equal to 1 by 4 pi epsilon naught q by r2 square into 4 pi r2 square, again r2 square cancel, 4 pi cancel, q by epsilon naught is the answer. So what we learn from it? We learn from it that you may take any surfaces. It in general for any surfaces. I have shown it in case of sphere, but if you take any surface like this and charge here q, then will be the total flux to the surface is equal to q by epsilon naught. It can be shown in the help of solid angle. Now then, if the force law in the form of electric field E equal to 1 by 4 pi epsilon naught q by r cube, then what will be the electric flux? Now this is asked in question that if the form is 1 by r cube in the form, that what will be the result of Gauss's law, or Gauss's law still valid or not? So to check the validity of Gauss's law, now we calculate flux. For this case, it will be equal to closed surface integration E dot ds. It is equal to closed surface integration. Let I omit the integration sign. 4 pi epsilon naught q by r cube into 4 pi r square is the total area of the sphere. Charge is here. So in that case 4 pi cancel, r square is cancelled by r, then the result is q by epsilon naught r. So we get that flux will decrease. Flux will decrease like this manner 1 by r. So the Gauss's law in that case will be that flux is this point is proportional to 1 by r. Flux is this point will decrease. So the total flux will not be q by epsilon naught, it will be q by epsilon naught r. So Gauss's law is not valid here. And also it is true that if the form of the law is 1 by r in place of 1 by r square, then in that case the flux will be 1 by 4 pi epsilon naught q by r into 4 pi r square, and r square r cancelled and 4 pi cancelled, then the result will be q by epsilon naught into r. So flux will increase and diverge. So as r increases, flux will be increased, so it will be not constant in that case also. So it is the beauty of the Coulomb's law that it has the form such that the total flux through any closed surface, you may take it is as small as a small marble, and you can take it as large as the size of earth or size of sun. In whole cases, in the all cases, the flux will be same. As you go to the infinity, then electric field is tends to 0, and so in that case the flux will be tends to infinity, and such that their product will be q by epsilon naught. So this was the answer to the question that if Coulomb's law has the form deviated from 1 by r square, it may be in forms of 1 by r cube and 1 by r. We get in the both cases that the electric flux will converge either or diverge. In case of 1 by r cube, the electric field will converge, and in case of 1 by r, the electric field will diverge, and in case of 1 by r square, the electric field remain constant for any types of surface. Thank you for watching the video.